Dr. Austin Hickman, founder and CEO of Soctera. Austin, welcome. And
So, thank you, everyone. My name is Austin Hickman. I'm the CEO at Soctera, where we are powering the future of wireless communication. The problem that we're facing is overheating of power amplifiers. These PAs are the workhorse component of any wireless communication. It's what allows a signal to travel from point A to point B. And overheating causes all sorts of issues for every wireless communication application. On the commercial side, telecom and SATCOM, you have reduced coverage, so reduced range of signals. And ultimately, when it comes to the commercial applications, it reduces the profitability due to the reduced coverage, but also the increased costs associated with cooling. On the defense side, it's all about performance, and so they're capped by this excessive heat in terms of range, image resolution, and then also bulky cooling requirements, which are difficult to transport in certain places or in certain environments. And so, what's the solution that Soctera is offering to this issue? We developed a semiconductor stack that is 10 times thinner than incumbents. What that does is get the device where the heat is generated 10 times closer to the heat sink. This was developed in electrical engineering and material science departments here at Cornell by myself and my co-founder. And so, what's the end result for the customer? uh, 40% longer signal range and 20% energy savings. Another twist to this that we didn't anticipate at first, but has come up is 20 times less gallium usage. So by shrinking everything, we were really targeting performance, but what we found now is, of course, we use a ton less gallium because of that. And gallium is a critical mineral that has supply chain issues. Right now, there's a lot of concern over sourcing gallium. So Soctera is inherently 20 times more resilient to any fluctuation in gallium pricing. So why now? So to give you a bit of the time scale, silicon has dominated the power amplifier space since power amplifiers became a thing. Back in 2010, a new technology, gallium nitride, emerged. And so as I mentioned, we're building off of the incumbent, the gallium nitride PAs, because they set the industry standard for what PAs are able to do today. And because they're able to achieve such high powers in the past 5 years, people have really discovered that what really limits these devices is the heat that they generate and the inefficiencies of the gallium nitride power amplifiers. And so right now, whether it's the engineering teams at Raytheon or the technology director at Ericsson, one of the major telecom OEMs, what they've all recognized is that thermals are what are limiting them, and a thermal solution will enable the next generation performance. And so I already mentioned a couple of these applications, but when you add them all up, they take up about 10% of the 13 billion power amplifier market. So 1.3 billion last year, anticipated to be over $2 billion just for these power amplifiers by 2030. So obviously these listed applications are very broad, but where are we going to go first? That will be the radio unit original equipment manufacturers for X-band radar, X-band being a specific frequency band. That, along with X-band electronic warfare for jamming purposes, as well as edge AI sensing, which is a new and emerging application that requires the best available power amplifiers. And so we've done a lot of work over the past really 4+ years developing this technology, taking it from the lab at Cornell and transitioning it to the industry and commercial production. So we've got to the point now where we expect to have our first generation products. This coming in 2026, we're in 2026, right? Summer this year, and we have customer requirements in hand. So it's very clear what we need to do and how we need to get there. And so the traction that we've gotten with our customers thus far, we've talked to everybody from the smallest of suppliers who can be great initial customers because of quick turnaround. And, when you approach them at the booth, you're talking to the CEO. From there, all the way up to the Lockheed Martin and Samsung, we have an ongoing relationship with Samsung evaluating our technology and how it can supplement their 5G base stations. And we've also determined what's the benchmark, right? So anything 25% or greater in power density is going to be an easy take for these customers. This quote we have from Empower RF is at 50% increase in power, they bend over backwards to get a sample. So looking at the broader competition, it's actually pretty simple. So there's three major players in the gallium nitride power amplifier market: Qorvo, Sumitomo, and MACOM. Of course, capable of high volume production, but missing that thermal advantage. There's a good amount of publicity out there about diamond cooling solutions, but the issue with diamond has always been manufacturability and cost, and so that still remains a limitation today. And so that's where we feel Soctera is really the only solution that has the performance advantages, but also the manufacturability with the added component of gallium resiliency. So similar to Thomas earlier, we are a fabless semiconductor company. We do not intend to build a $100 million fab, not yet. So we uh, own the IP and the designs around both the material design, which is where the core innovation is, but then also the design of the power amplifier that is built on that material. To give you, if you can see me on the camera, this is what a wafer coming out of the line looks like. So if there you go, you can see some of the patterns just to give you a visualization. And then you dice that into pieces and package it into these components. And so when you get through the end, what we find is we have a significant profit margin of around 90% on these devices. So the team, myself and my co-founder Reet, who also we were lab mates in the same group here at Cornell doing our PhDs, advised by our advisors, our PhD advisors, great Professor Grace Xing and Professor Debbie Jenna, and also advised by Robert Scharf, the director of Praxis, and Bruce Fishbein, who has tons of industry experience in the semiconductor space. Thus far, we've been powered by non-dilutive grants from NSF, Army, Air Force. So we've been able to push through the past several years of technology development on those grants and maintaining the company to ourselves. But now we feel the time is right. And so we're actually kicking off a seed raise, which I'll talk about on the last slide. So just to get towards the end here, where we want to go with this, we want to aggressively pursue the power amplifier market, targeting $100 million per year revenue within the next 4 years. And that revenue streams will come from major contracts, primarily with the DoD, but then also OEMs and telecom. And so finally here, the ask, we're currently raising a $5 million seed round to double the size of the team from 3 to 6 and enable the manufacturing required to get our first power amplifiers into the market. And so with this, we'll demonstrate the first few steps of the revenue roadmap, over $1 million in revenue by next year, and put ourselves in a good place for a Series A raise. And with that, I will stop and take any questions.
Thanks, Austin. Any questions?
Yeah, I do have a
Rajiv?
question. Oh, okay. So as of today, do you have, I mean, like you showed the wafer, and do you have
Yep.
any evidence on the yield or the RF stress reliability or the wafer compatibility
Yeah.
and also the foundry scale production limitation feasibility, basically?
Yeah.
Why I'm asking is that like we know that like thinner stacks often trade like thermal gains, am I right, for manufacturing
Mhm.
risk. So I come from IBM, so I've done like thin wafers a lot. So
Yeah.
that's why that's where the question is.
Yeah, yeah, it's a good question.
Mhm.
And so we definitely know that we're compatible with existing foundries because we've actually run our wafers through two of the largest foundries in the US, including the one we're now partnered with, and are doing our production through. And then in terms of yield, yeah, we also don't have any issues in terms of yield because ultimately we're still using the same substrate material as the foundry. So there isn't a difference in handling for the vast majority, really the entire process. So, in terms of, I know you're probably thinking when you thin down, it gets brittle, like there's difficulty of consistency. The substrate material behind the stack that gets thinned down at the last step is the same. It's silicon carbide is what it's the standard for the RF GaN industry today. So we're working on getting the reliability data from the first wafer that's gone through our foundry process. That's actually underway right now. So we should have that data soon. But yeah, we don't expect any added difficulties because of the change in the stack in terms of yield or manufacturability.
Okay, thank you.
See, Dan has his hand up. Yeah.
Yeah, Austin, how are you?
Hey,
Great
good.
job.
Yeah, thank you.
Question for you on you were talking about your beachhead market, radio unit EMs for X-band radar, electronic warfare, and edge AI. Can you talk a little about edge AI? They sort of slipped that in there. Tell me a little bit
Yeah,
about that and the
yeah.
opportunity.
So, it's really an emerging topic that I'm just becoming aware of
Okay,
for the RF GaN space. Of course, we see AI taking center stage for power GaN devices.
right.
On the RF side, of course, we're not in the data center, we're at the edge. And so this idea of kind of distributed AI, right,
Yep,
outside of the data center at the edge,
yep.
that's where there's because you're having that much compute and that much information being processed at the edge, you then have this need to transport that data at high bandwidth. And so there's this emerging application for these power amplifiers, whereas previously it hadn't been seen that way.
Right.
Yeah, so this is, I think, very new and something really I've
Okay.
come to know about just in the past couple months.
Right. Yeah, just
Yeah,
like the rest of us.
yeah,
Perfect. Thank you.
yeah,
Yeah.
definitely.
I was actually going to ask you, Austin, about I mean, you and I have been exchanging some emails about trying to connect with investors.
Yeah,
There's certainly a lot of appetite out there, as we all know, in AI, right? Both on the software side, application side, and infrastructure as well.
yeah,
Are you finding, I mean, maybe that the fact that you can perhaps play in that space
yeah,
might actually open more doors for you. I don't know. You
definitely.
probably haven't noticed that yet, but are you finding in general that you're getting enough interest?
Yeah. I think it's well, I've been having initial conversations over just really the past couple weeks.
Hmm.
And so yeah, it's an interesting time. You hear all the market's not good or all the market's great for your specific area right now. I think one thing other than just AI we've been trying to play up is, this American dynamism topic and resiliency of U.S. domestic supply chain was something that we were already kind of on that train, and now
Hmm.
that's become an investment area. And
Yeah.
so trying to take advantage of that as well. And that's, I mean, just to be very honest, right, adding in the gallium resiliency thing. Again, we had no idea or weren't even thinking about reducing that amount of gallium we were using, but now that's become a significant topic. So
Hmm.
yeah, trying to leverage what the message that resonates, right? Yeah.
Hmm. Very good. Thank you. Any other comments or questions from anyone? If not, yeah, again, I would encourage people to maybe connect with Austin offline.